Good afternoon and welcome to Webinar Wednesday. We are excited to have over 200 registered attendees for today's webinar, which is eligible for 1 credit from the ACI. Let's get started by giving one lucky attendee a Webinar Wednesday lunch bag for answering this trivia question. What is Ireland's national symbol? Answer now using the questions feature on your dashboard. While you're answering, I want to invite everyone to join us for the Spring MD Expo conference, which will bring HTM professionals from across the nation to Nashville, April the 4th to 6th, for 3 days of learning, networking, and the latest advances in technology, products, and services. Register now using the Webinar Wednesday VIP Pass, which can be found in your webinar workbook. More details can be found at mdexposhow.com/Nashville. I would also like to bring to your attention our Professional of the Month series. If you'd like to nominate a colleague, please download the document in the handout section of your dashboard. This contains a link and more information. Okay, and let's see who the winner of our Webinar Wednesday lunch bag is. And congratulations to James Tuft. The correct answer is the Celtic Harp. Webinar Wednesday would like to thank our sponsor, Universal Medical. Universal Medical has nurtured a business philosophy founded on offering comprehensive nuclear medicine equipment services at a reduced price. Their products and services include new and reconditioned nuclear imaging systems, quality parts, excellent equipment service, training courses for healthcare technology managers, camera system moves, technical and clinical support, flexible financing options, and more. Visit www.uni-med.com for more information. Our presenters today are Chad Watson, Evaluation Program Director at Universal Medical, and Ann Hamilton, Radiology Director at Texas County Memorial Hospital. Chad, you may begin whenever you are ready.
Okay, hello everyone, and thanks for joining us today. My name is Chad Watson. I'm with Universal Medical, and I'll be going over the importance of a system evaluation with you today. I'll start off by going over the agenda and the objectives. Why is it important to have your SPECT camera evaluated periodically? We'll do an overview of what must be included in an evaluation and how you can use the information. We have a guest from Texas County Memorial Hospital to go over her profile and her experience during and after her evaluation was performed. Then we'll talk about actions you can take after receiving the results of your evaluation to improve the performance and the useful life of your camera. Then we'll do a question and answer session. So now let's talk about why it is important to evaluate your SPECT camera system. Your camera may be used to diagnose 50 patients a week, but who is diagnosing your camera? There are several reasons to have your SPECT system evaluated periodically. One is to gain an understanding of the operational effectiveness of your system. Just because it is operational does not mean that it is operating at a peak performance. What can be done to improve the performance of the system, minimize your downtime, and avoid costly repairs? There could be hidden problems that haven't been an issue yet, but are likely to surface down the road. Evaluating the system can find some of these problems now and prevent downtime later. Knowing the operating condition of your system is important in determining your service needs as well. Another reason for an evaluation is to learn the market value of your system. Is your system worth the current service contract that you have to keep it running? What is the financial impact of your system, and how does it affect your department from a clinical standpoint? In other words, is money being spent on the system necessary, and does it interfere with patient care? Ultimately, an evaluation will allow you the ability to make an informed decision about nuclear imaging investment. It will give you the insight needed to determine if you should repair, upgrade, or replace your equipment. Now, let's look at these reasons a little more in depth, starting with the operational effectiveness of your system. Is it running at peak performance? Let's think about our vehicles for a moment. Your car may start up in the morning and get you to and from work, but what if it could do it more efficiently? For example, if you replace the fuel and air filters, your gas mileage could increase. And changing your oil on a regular basis keeps sludge from building up, which extends the life of the car. Your nuclear system is a lot like your car. Taking care of these little things now can prevent downtime and costly repairs later. During an evaluation, we will look at how well your system is operating. We will look at each part of the system and analyze it. The gantry, table, exchangers, acquisition and processing computers, and mechanical motions will all be examined. We'll even look at the room setup and the environment surrounding the system to make sure that it is all efficient. If it is not running at peak performance, what can be done to improve it? One thing that can be done is to pay attention to your system. For example, is it making a new noise? You need to investigate that noise or have someone else check it out. A simple calibration or realignment may be all that is needed. Give the system the attention it needs when it needs it, and it will perform at a higher level. Are you keeping up with your PMs? Not just doing the PMs, but are they being done correctly? Is old grease getting removed and new applied? Are the fans being replaced and motions adjusted? Are you following OEM standards when you perform the PMs? Should new corrections be burned and applied, resulting in better image quality? This is better to do on a scheduled basis rather than an emergency one. It seems like we're always shipping linearity plates overnight to customers so they can calibrate things the next day. That's an expensive shipment that can likely be avoided by paying attention to uniformity numbers. Could replacing a fan or power supply extend the life of a system? Maybe you're experiencing image quality issues caused by a faulty power supply. Replacing these things now can be done for low cost and little downtime, but they have a big impact on the efficiency of the system. Replacing the brushes on a motor or a seal on a gearbox could quiet down the system and prevent unnecessary wear. This could prevent you from having to replace the whole motor assembly at a higher cost. Processing computers are often overlooked when it comes to performance. They should be kept clean and in a well-ventilated area. They are often stuffed under a desk and not cleaned on a regular basis. A dirty and hot environment will shorten its lifespan considerably. We receive a lot of calls for service because of file system full errors. This means that there is no more room on the drive and it cannot function. As the drive fills up, the computer could start to operate at a slower rate. Patient files should be backed up and removed from the drive on a regular basis. This will keep the drive functioning and performing at a better rate. Another key factor in a system's operation is how or if it is networked. Most sites are somehow connected to an environment outside of their room. This could be as simple as another room in the department or somewhere in the hospital, or as complex as anywhere in the world. A lot of sites utilize a PACS system for archiving data from their camera. What type of hardware is used to handle this communication plays an important role in how well it functions. There are many brands and styles of hubs and routers available. This is the hardware that connects the system to the outside world. We will evaluate what you have on site and may recommend that you change them out to increase the security and efficiency at which data is sent. Some of these have high fail rates, and replacing them could save you some frustration. During an evaluation, we will also document the information used by the system to communicate. Whether the system only communicates with itself or the outside world, it has a network structure. Documenting the IP addresses and the MAC or Ethernet addresses associated with the system is very valuable when something needs to be replaced. One of the most efficient and effective methods of restoring your system to full operation when a hard drive fails or is corrupted is to clone or back up your hard drive. Do you have a method for backing up your hard drives? All of the system's functions are saved on the hard drive, everything from the addresses we just mentioned to the corrections for the detector. If a hard drive fails, it could take several hours or days to reload the software, then require corrections and get the camera back to a clinical use state. We may make recommendations on how you can save this information and therefore save a lot of downtime and service costs. Knowing how well your system is functioning is important when determining your service needs as well. Whether or not you have a full service contract or do service on a billable basis, an evaluation will inform you of actions you need to be taken to get your system in a good operating condition. Knowing what repairs are needed will be valuable when you're setting your department's budgets, as you can plan for repairs that need to be made. A thorough evaluation will expose potential problems and answer the question of how efficient your system is operating and therefore will improve the operational effectiveness of the system. Now, what is the market value of your system, and how can an evaluation help determine this? To determine the value of your system, we're going to look at the system as a whole, as well as the individual components of it. How old is the system? What is the availability of parts? Can you find a reputable service source? These are some of the questions that need to be answered to determine the value of your system. These things will be used to determine the market value and its value to you. Let's use a Vertex Plus as an example. Your system may have been produced 15 to 20 years ago. The OEM has declared end of life for this product. However, you can still get individual parts from multiple sources, and service providers are still readily available. Now, the market value of this system, if you were to trade it in or try to sell it, would be very low, maybe around $1,000. You may even have to pay someone to come remove it from your facility when you're ready to part ways with it. However, it still has value to you. You're using it on a daily basis as your main camera or even as a supplement to other cameras in the department, and it is still producing revenue. It has little downtime, and you may have it under a service contract or even be billable for service, but it's not costing lots of time and money to keep it running. So even though the market value is very low, it has a big value to you. Now, in the case of a Vertex Classic, we might not get that same result. The market value of the system is closer to, say, $0. The system is 20 years old and also at end of life. However, individual parts, let's say for the auto exchanger, are rare and costly when found. Furthermore, it's hard to find anyone that will put the system under a contract, so everything is done on a billable basis. You are experiencing a lot of downtime. As a result, you have lots of lost revenue. Due to the fact that the system frequently goes down during a patient study, you'll have patient inconvenience to factor in. So as a result of an evaluation, we can determine there isn't any market value, little revenue is being produced, which means there isn't any real value in the system to you, and it's time to make a move. Now, in both of these examples, we used older systems in our evaluations. Both of them were at an OEM end of life. What if your camera is not? Maybe your system is closer to 8 to 10 years old. How can you determine the value of this system both in the market and to your department? Well, we use the same evaluation standards to determine their value. Are parts available? Who can service the equipment? Maybe more important in this case is if the system has experienced a lot of downtime, causing you to lose revenue and inconvenience patients. If so, maybe take time to take a look at other options. Aside from the system's age and availability of parts and service, there are a few other things to consider when determining a system's value. For example, during an evaluation, we look at detector types. Many cameras have several detector options, like even analog or digital models. In the case of a Siemens eCam, there are several models like HD3C, HD3R, HD4, or 4-site detectors. Some sites don't know what kind of detectors they have. The camera may have been installed before they arrived at the site, and they don't know the difference or how to determine the differences. When it's time to sell the system, it's going to be difficult for them to get a true market value since the detector type greatly affects the price. Have the detectors been upgraded to the newest option? Or how many collimator sets are there? And is the most popular ones included, like LEHR and BXH? We will look at the acquisition and processing computers and see what model they are and if upgrades are available and what version of software they are running. Software versions can play a big part in the system's market value. If your system lacks the basic software, for instance, AutoQuant or AutoSpec for processing, or if you do not have the latest version, then the market value could be less. Also, if you're not running the latest acquisition software, the market value could go down. Not only what is loaded on the system, but the hard copies available as well. Acquisition and processing software is also in the system's value to you. Upgrading the software may allow you to operate more efficiently or offer products currently can't. This could allow you to increase your department's revenue and therefore the system's value to you. Unfortunately, there is a formula written in stone that can determine the market value or the system's value to you, but an evaluation can determine the financial impact of the system and how it affects your department from a clinical standpoint. So an evaluation is a critical tool that should be utilized to answer these questions. Now that we've examined several reasons to perform a system evaluation, let's talk about what should be included in an evaluation. There are 4 main inspections that should occur during an evaluation, and they are an environmental inspection, mechanical inspection, detector inspection, and image quality inspection. Each inspection is crucial in determining your system's operational efficiency status and its market value. Let's examine each of these and talk about what should be involved in each one. First, we'll look at the environmental inspection. How your facility is set up and maintained can be a crucial factor in the efficiency of your system. The biggest thing to look at here is the temperature and humidity in the room. Gamma cameras are little heat factories when they're operating, and high temperatures and electronic components are not a good combination. An optimal room temperature is between 72 and 74 degrees. If you're consistently operating at temperatures above this range, you will shorten the lifespan of the electronic components on your system. High humidity can also damage the components of your system. Not only can electronics be compromised, but in the case of humidity, rust may form on mechanical parts. It is important to maintain good temperature throughout nights and weekends as well. Some facilities will bump the temperature up at night or at times when the room is idle. The system is still producing heat at this time and will need to be cooled. Another factor to consider is proper ventilation to the system. Detectors, computers, and UPSs all have fans that keep them down. If there is not good airflow to these parts, they too could have a shortened lifespan. When the system is parked for the night or any extended period of time, the detector should have good air movement. If not, it should be moved to another position. A good example here is in the case of the Vertex Plus. When it is at the home position, one of the detectors is in the belly of the camera. It's generally hot in there and there's not a lot of airflow. It's better to rotate the gantry 90 degrees so that both detectors are out of the belly. Consider the positioning of computers or any other equipment with cooling fans. If they're located under desks or in corners, panels that allow airflow may be blocked. This will most likely result in untimely failure and service calls. An environmental evaluation will provide you with the proper room setup, ensure that temperature and humidity are at proper levels, and that ventilation is adequate. Second, we need to do a mechanical evaluation. This will involve looking at all the moving parts that are on a system, as well as the things that control them. The main thing here is to check that all motions move properly and smoothly and at an appropriate noise level. Loud noises during movement are a good indication that something is failing. Motors and gearboxes may be misaligned, and something as simple as realigning them can prevent failures later. Bearings or brushes could be squealing. This is going to cause an uncomfortable noise level for everyone in the room. These need to be addressed to prevent further damage to the motor and possibly a replacement down the line. All mechanical assemblies will be checked for proper lubrication. If there's not enough grease on the assemblies, excessive wear can occur. You also need the right kind of grease. It has to be able to handle the pressure applied by the motion as well as the temperature created by it. And if you get hard or gummy grease, it can cause a motion to lock up and not move at all and be removed and reapplied. A prime example of this is on a Philips Forte. Our service engineers have been dispatched on multiple calls due to detector radiuses not moving. Upon arriving and investigating the problem, it was found that the guide rails had hardened grease on them, and it was completely stopping the motion. These rails are not supposed to have grease on them at all, but oil should be applied. Once the old grease was cleaned off and the right lubrication was applied, the motion worked smoothly. But those calls could have been avoided. These things will be looked at during the mechanical portion of the evaluation. The camera assemblies will also be checked for their metal shavings and leaks. Again, shavings are an indication that something is not aligned correctly and need to be addressed to prevent failures and downtime. Leaks will be checked and indicate that a seal is bad or a bolt is loosened. In either case, the gearbox will not have proper lubrication. Pre-programmed motions will be checked during the mechanical inspection as well. The commonly used motions, such as a home or a patient load, will probably be fine. But some motions, like an out room, may only be used once in a great while. The sensors and locks that are involved in these motions often will fail when they're needed. When these motions sit idle for long periods of time, they often lose their calibrations due to sensors moving or failing. Again, here's a situation where a patient study is interrupted, resulting in downtime and lost revenue. This is why all pre-programmed motions should be checked and evaluated. It's important to pay close attention to the mechanical noises and signs that your system gives you so that you can be proactive and prevent high-cost part replacements. Now let's move on to the detector inspection. Here we want to ensure that the detectors are in a stable environment. The power supplies will be checked for proper voltage and noise. If voltages fluctuate, image quality could suffer. A noisy power supply, meaning that there's an AC voltage reading on DC output, could also affect the image quality. As a result, power supply voltages and noise levels should be documented. Then, in the event of a change in image quality, there is a benchmark for power, and it will be easier to diagnose and repair. The environment inside the detector cover should also be inspected. Detectors are especially vulnerable to high temperatures and dirt or dust bunny buildup. Fans and fan bearings will be checked to ensure that there's proper airflow. We've seen a few instances where customers needed service because there were no counts on the detector. After troubleshooting that problem, the cause was found to be a power supply. However, the cause of the power supply failure was heat-related due to the fact that the fan bearings were locked up and the power supply vents were blocked by dust bunnies. No air was getting to the power supply at all. So again, we have an instance where downtime could have been avoided by a periodic system evaluation. All of the wires and connectors involved with the detector will be inspected as well. They need to be checked to make sure there are not any loose connections and that any method of securing them, like clips or screws, are also tight and secure. A slight change in the detector environment can cause a shift in image quality and make it hard to diagnose. Evaluating the condition of the detector may be helpful when a problem does arise. Finally, let's discuss image quality and what can be determined during an evaluation. Image quality is perhaps the most important feature of a nuclear imaging system. It is an important tool used to properly diagnose and treat patients, and therefore should be monitored closely. During the inspection, we'll review the QC logs, check conformity numbers, look at bar resolution, and COR numbers. All of these things are used to identify a uniform image. QC logs can tell us how an image is performing over a period of time and when we need to take action to maintain good image quality. We will perform a hydration check on the crystal. By acquiring an image both above and below peak, we can determine if a crystal is hydrated and what action needs to be taken. Then we will acquire and analyze images without corrections applied. This will tell us the integrity of the image from the ground up. If energy and linearity numbers are high, then corrective action needs to be taken and not just masked with the uniformity correction. The uniformity correction should only be applied if the image is operating within specifications. By analyzing this now, we can keep the image quality within spec. Another thing to consider with image quality is accreditation. Your images may look great and have numbers within specs, but if they're being masked with corrections, they will most likely not pass ACR or ICAL accreditations. So we need to evaluate them now and take actions to get them back to a passing state. We also look at the peak of the detectors during the image inspection. Keeping the detectors on peak will ensure the image quality is good, and if there are any non-uniformities in the image, that they're not being caused by the detector operating out of range. We will run through some mock studies depending on the function of your system. Whether or not it's a cardiac unit or a general nuclear camera will determine what additional studies are done. For example, we may do a spec study to make sure that the cardiac gate signal is getting through, or a total body study to make sure that the camera moves at the correct speed. It's very frustrating to schedule your patient, order the isotope, and set up the study only to find out the camera won't function. So running a mock study during the evaluation will ensure the studies you acquire are within spec and save you the frustration. Finally, we will look at the room setup and determine if anything may interfere with or give false readings when tuning or diagnosing the image quality. Hot lab locations, misplaced trash can, or sharp container that has traces of radiation can significantly interfere with the tuning of the detectors and therefore affect the image quality. So they may need to be removed or relocated. Now we've talked about the reasons to have an evaluation on your system and its importance to you, and we've also discussed what can be expected during the evaluation. At this time, we have someone with us who has gone through an evaluation, is here to share that experience with us and tell us the things she was able to take away from it. I would like to introduce Ann Hamilton from Texas County Memorial Hospital in Houston, Missouri. Ann, would you tell us a little bit about your facility and how your evaluation process went?
Thank you, Chad. Hello, everyone. I'd like to share a little information about myself in Texas County Memorial Hospital. I've been working in the radiology profession for 39 years, with 30 years in a supervisory or chief tech role. I worked several years at Phelps County Regional Medical Center in Rolla, Missouri, and my current management position at Texas County Memorial Hospital the past 19 years. I am a working manager. So during my work shift, I wear multiple hats. In addition to my management duties, I perform sonograms, complete radiographs, and help out in the front office. The majority of my staff is multimodality trained and credentialed. Texas County Memorial Hospital is a licensed 66-bed acute care hospital located in South Central Missouri. Texas County is the largest county in the state. Therefore, we provide services to a large community and surrounding area. The larger healthcare facilities are up to 1 hour from Houston. TCMH is vital to the community for healthcare, but also is one of the largest employers. Our facility has level 3 stroke designation, level 4 STEMI designation. And our physician services we offer are general surgery, internal medicine, family medicine, pulmonology, obstetrics, gynecology, and emergency medicine. TCMH Radiology provides a full line of services including MRI, computed tomography, bone density, digital mammography, ultrasound, digital radiography, and nuclear medicine. We contract with a company to provide nuclear medicine staffing, radiopharmaceuticals, and to manage all NRC regulations. The equipment is owned by Texas County Memorial Hospital. The primary nuclear medicine exams performed are cardiac stress, HIDA, bone scans, and gastric emptying studies. In 2013, we completed a major expansion project, which included a new radiology department. During the expansion, we upgraded the nuclear medicine equipment. I worked with Universal Medical to assess our needs, and it was determined to install a dual-head ADAC Forte camera. That leads me into sharing my experience regarding the equipment evaluation. Universal Medical contacted me last fall. Chad explained the equipment evaluation program and wanted to know if I was interested in it. He mentioned it would be performed as part of our service contract. I agreed to have the equipment evaluation completed. However, the thought came to me this might be a way for Universal to have us upgrade to a newer camera. I can tell you this is not what happened. Universal Medical completed the equipment evaluation in December, and the results indicated our equipment to be in good working order.
Okay, thanks, Ann. So you mentioned that Universal Medical did a site inspection for you before you purchased your system. How was that valuable to you?
Oh, well, site survey is important to do before you make any equipment investment, as it can determine what kind of system to get, how the room should be set up, and what to include. Universal gave us 2 options, and we decided the ADAC Forte best fit our needs.
Okay, so when the evaluation was complete, you received the summary, and then a call to go over what was all found on your system. And then you mentioned you thought we were maybe just trying to upgrade your system you have. Is that right?
Yes, I must admit, for a brief moment, I thought the evaluation might be a way to have us upgrade to a newer system. Then I decided I should just wait and see what happens. As it turned out, no problems were identified with our system.
Okay. And then the evaluation, it can be used to justify a replacement, but in your case, that wasn't necessary. The evaluation was helpful in making your department budget and planning your service needs.
Yes, the evaluation, it provided valuable information for potential capital budget expenditures and the ability to prioritize those needs for us. Knowing beforehand what the service is or is not required for that piece of equipment or replacement of it makes the budget process easier. And Chad, that comes to mind since we've had this evaluation. How often do you recommend that evaluation be performed?
Okay, well, that's going to depend on several factors. It's going to depend on what condition your system is in, what's the age of your camera, are you consistently having problems or downtime? If you do or you are experiencing a lot of downtime, I would say you'd want to do 1 or 2 a year just to stay on top of things. If you don't have a regular service provider, then you would probably want to do them more often. If you're keeping up with your PMs and you're doing PMs once or twice a year, then you could use that time as an evaluation as well, and then you wouldn't have to schedule them as often. So Ann, what else were you able to take away from your equipment evaluation?
Well, the expertise and knowledge of the service staff at Universal Medical. For rural facilities, high quality service is a priority, and actually that's how we sometimes choose to keep equipment and our next purchase of equipment. This process proved to me that your staff is very competent at their job, and also the condition of my system, and what actions I might have to take. I got peace of mind in knowing that my system is in great shape, and I was able to use this information in my budget and gained ability to prioritize these needs.
Okay, well, thank you, Ann, for sharing that experience with us. So after the evaluation is complete, you should have a good idea of the condition your system is in. You will have the summary sheet sent to you and receive a phone call or even a face-to-face meeting to discuss and explain each part of the evaluation. All of the problems or potential problems will be explained in detail and recommendations given. We may find that your system has passed all inspections, but recommend an action be taken. For example, your system passed all the image quality tests, but the linearity correction, which should be acquired every 2 to 3 years, is right around 2 years old. It still produces good image quality, but we recommend that you reacquire it and apply it. Then this can be scheduled, let's say at the next PM, to save on downtime and travel expenses. At the end of the evaluation review, you should know everything you need to know about your system. At the very least, you will have all the site and system information in one document. Your name, location, and site contact information, the camera's make, model, and serial number, the data manufacturer, detector model, and collimators, the make and model of the acquisition and processing computers, and you'll have a list of all the software loaded on your system, both the acquisition version and the processing versions. Again, this is very useful in determining the market value of the system. We will note the service history of the system and the date of the last PM. As we discussed earlier, you will know the state of the room environment, the mechanics, the detectors, and the image quality of your system. We will note if there are any other cameras or equipment in your department, and we'll even provide a room drawing. That could be valuable if you ever have the need for an install, a move, or a deinstall. So after receiving the results, you should be able to make a choice on your equipment. You will either repair it, upgrade, replace, or do nothing with your system. But use the facts. Maybe overall your system is in good shape. After the evaluation, you decide your system fits you, you can still produce revenue and service patients and your department well. There are a few items to take care of, like a leaking gearbox or a loud fan, so you repair these items and continue on with the system. Perhaps the core of your system is good. Motions all work, image quality is good. It's possible you just need a computer upgrade or a new version of software. As a result of that upgrade, you're able to provide to service patients more efficiently, and your revenue increases, as does the system's value to you. The results could prove that your system doesn't have any real market value, you're experiencing a lot of downtime, and the service is hard to find. It's time to purchase a new system. Whether or not you purchase a new or reconditioned system can be determined from the result of the evaluation. As in the case of Ann at Texas County Hospital, you have an excellent service provider that keeps your system in tip-top shape. It fits you well, produces a lot of revenue, so there isn't any action to take except keep doing what you're doing. So as you can see, a nuclear system evaluation is an important tool. It will provide you with the operational effectiveness of your system, the market value, and the system's value to you. A periodic evaluation can be a key instrument in determining your service needs, preventing downtime and costly repairs. It gives you the information necessary to decide if you should repair or replace your system. Whatever your choice may be, an evaluation will give you the ability to make an informed decision about your nuclear system investment. So thank you for your time and participation in today's presentation, and now we can answer any questions that you may have.
That's great. Thanks, Chad. Yes, we have had a few questions come in. The first one is, when you perform the evaluation, how often do you find the camera is not operating to specifications?
We find really quite often that something's going to be wrong. You keep in mind that these systems are very complex. They have a lot of pieces and moving parts to them. So finding something wrong is usually not a problem. Now, we don't want to get down to the nitty-gritty, or we want to make suggestions to keep your camera running for a long time and functioning efficiently for the department and for taking care of patients and producing revenue. So anything we find, we're going to recommend that you replace or repair. It doesn't mean that you have to follow those recommendations, but we can almost always find something that's not operating to a specification.
Okay, so if the camera isn't at specification, will your service person tell us what we need to do to get the camera operating to specification?
Oh, absolutely. Yeah, that's the one of the big things about the evaluation is when we're done, we will go over the summary with you and point out everything that we found and make recommendations on what you need to do to get it back to functioning properly, and not only, you know, just make it more efficient for you over the life of that camera, and hopefully we can prevent some service calls and prevent some other problems from happening.
Okay, and so how long will an evaluation take?
That can depend on the type of system you have and the environment that you're in. Typically, for like a single head camera, it's going to take about 3 or 4 hours, and that's really going through everything. You know, we have to remove panels. You're going to take some images and then evaluate all that stuff, take the notes on it. On a dual head camera, if it's in a bigger facility, you know, we take into account, like I said, the environment of the room, so we have to investigate that. We're going to go through all the mechanics. And then there's 2 heads that you have to deal with as far as taking images and doing setups, removing collimators for intrinsic and putting them back on and stuff like that. So those cameras for a dual head, they could take anywhere from, you know, 6 to 7 hours, and probably would schedule like a whole day to get through a dual head evaluation.
Okay. Will I receive actionable information as a result of having my camera evaluated?
Yes. Again, we go over that information. You know, the summary will be given to you, and then you'll get a call that tells you what actions need to be taken from that summary and go into detail on each of the investigations we did on each of the different camera parts. You know, actions can be taken. We've had instances where customers have called us and explained that they need to replace their system, and then we go into a little bit of detail with them and find out that they're having problems on a continuous basis. They're breaking down. They can't find service and they can't find parts. And then we go in and investigate and evaluate. And after evaluating their system, we're able to recommend that they just repair their system. You know, I've had instances where image quality and tube were an issue and coupling was an issue on detectors, we were able to go in there and take the thing apart, recouple the heads, put it back together, calibrate the corrections, and get the image quality back to operating within specs. Then we repair the motions they have, the problems they have with those. You find faulty motors and gearboxes, and we take those apart, redo the seals, redo the brushes on the motor, clean everything up, put it all back together, and then at the end of the day, the thing's ready to use again. And a lot of times they really like their system, they don't want to get rid of it, and we're able to repair it instead of replacing it. So there's anything from a small action item to a very large action item, but we will definitely go over the options with them.
Okay, and can the evaluation be performed remotely?
I would say not. Part of the evaluation process is getting your hands and eyes on the system. As I mentioned, there's a lot of panels to take off. You got to get to radiuses and stuff like that, and the panels on a table to look at the mechanics on that. So, everything needs to be removed. And then, we're really giving you kind of an expert eye on the situation. You may look at it and determine that, yeah, that grease on the radius assembly looks fine. It's all greasy. I can see that. But you don't know that grease is old and hard, and it's probably going to cause problems down the road. And again, your image quality, you may take your uniformity numbers, look at them, and say, yeah, they look great. But once we dig in and do some off peaks and stuff like that, we're going to find other problems that you're not familiar with or don't know what to look for. And that's why we would do the evaluation, to give us the expert look at what needs to be done to that system.
Okay, that's great. We haven't actually had any extra questions, so we will wrap up now. So I'd like to thank you both for a great and very informative webinar, and obviously thank you again to today's sponsors, Universal Medical. Now, one lucky attendee will win an Amazon gift card for completing the post-webinar survey, which will appear on your screen shortly. You must complete the survey to obtain your certificate of attendance. Now, if you don't see the survey, please email us at webinar@mdpublishing.com. For more information about our upcoming webinars, please visit our website, webinarwednesday.live. Have a great rest of the day, everyone, and hope to see you next time.